3 in 4 women on the Titanic survived. Most men didn't. That gap isn't a story. It's sitting in a spreadsheet of 891 real passengers. And by the end of this video, you'll pull it out yourself in about 30 lines of Pandas. No memorizing syntax. Just learning to interrogate data and not get fooled by it. Here's the whole plan on one slide. We load the data, look at what's broken, then slice survival 3 ways. Sex, class, and age. The one rule I want to burn in early, we compare rates, not headcounts, because the groups aren't the same size. Absolute numbers will lie to you here. First move, always. Load it and look at it. Shape tells me 891 passengers and 12 columns. D types tells me what Pandas guessed each column is. I've been burned before trusting a dataset I never printed. Turned out a whole column was strings pretending to be numbers. Look first. Real data has holes, and this dataset is famous for them. Age is missing for a chunk of people, and cabin is basically empty, almost 700 blanks. We're not fixing all of that. We just need to know it's there, so our age analysis handles the gaps honestly instead of pretending they don't exist. Here's the trick that makes this whole project easy. Survived is coded as 0 or 1, so the average of that column is literally the survival rate. Group by sex, take the mean, done. And look at that gap, roughly 3 in 4 women survived versus fewer than 1 in 5 men. Women and children first wasn't just a saying. Same one-liner, different column. First class survived at 63%, third class at 24%. The pattern's brutal and clean. The higher your ticket class, the closer your cabin was to the board deck, and the better your odds. 2 variables in, and the story's already writing itself. Age is a continuous number, but survival rate per exact age is noisy garbage. So we bucket it with pd.cut into child, teen, adult, senior. The nice bonus, rows with missing ages just don't land in any bucket, so they quietly sit out instead of corrupting the result. Children do come out ahead here. The children first half of the saying holds up. This is the one idea I actually care about you taking away. If I plotted raw survivor counts, third class would look fine just because there were so many of them. Comparing groups of different sizes with absolute numbers is the most common beginner trap in all of data. Normalize to a rate, and the truth stops hiding. Now we draw it. We already computed the rates, so plotting is just calling dot plot on that little series. No extra work. Honest opinion, for a project this size, plain matplotlib is plenty and Seaborn is a bit overrated. I only reach for Seaborn when I want the nicer defaults for free, like on the age histogram next. Last chart, and it's the payoff of everything we said about rates. We overlay the age distribution of survivors versus non-survivors, and the key flag is stat equals density with common norm off. That normalizes each group to itself. Without it, the bigger group just towers over the smaller one and tells you nothing. With it, you can actually see the little bump of surviving children. Here's the whole thing in one screen, load, inspect, 3 group bys, and a little loop that saves both bar charts so we don't repeat ourselves. Under 30 lines, and it answers the entire question we started with. Clean. Run it and the console fills with those rate tables. Then 3 images drop into your folder. Reading them top to bottom, sex is the loudest signal, class is second, age is 0 but subtler. That ordering is your finding. You didn't guess it, the data handed it to you. If you want to go one level deeper, cross 2 variables at once, group by sex and class together. That's where it gets genuinely interesting. Does being first class save a man? Or does being a woman in third class still beat him? Answering that one line teaches you more about the disaster than any single chart did. Here's what makes this feel like real analysis. You never decided sex mattered most. You ran 3 group bys and the numbers themselves lined up. Sex first, class second, age real but quieter. The data ranked its own killers and handed you the order. That's the difference between guessing and knowing, and is the whole reason we normalize to rates instead of counts.